Good morning students, Sairam, this is Megha Miss here, and today we will continue with our lesson number 9, that is carbon compounds. Okay students, this is our session 6. Now in session 5, if you have went through it, I have told you about the paper pattern. Also we have continued with the lesson also, so I hope you have went through it. So in the last presentation students, we studied about, if you remember, we saw the functional groups, homologous series, right? And we have seen different types of carbon compounds can be formed. Okay students, so we'll continue with the lesson today. Now the today's most important part we are going to study, that is the nomenclature system of the carbon compounds. Okay, A is the system of common names. Initially, when the number of known carbon compounds was small, scientists named them in a variety of ways. Okay, now those names are called common names. What you will call them as the common names. For example, the sources of the names of the first four alkanes, namely methane, ethane, propane and butane, are different. The names of the alkanes thereafter were given, yes, from number of carbon atoms in them. Means students, how many carbon atoms were present, depending upon that the name was given to that particular carbon compound. Okay students, now see here. Two isomeric compounds having a straight chain or branch chain in their structural formulae are possible for the molecular formula C4H10, that is butane. The difference and the interrelationship in them was indicated by naming them as N-butane, that is normal butane, and I-butane, that is isobutane. So you can have two structures, different structures of butane. Okay students, so we call them as isomers, right? So they were given the name as the normal butane and the isobutane. Okay, so we'll study now. This is a very important nomenclature system students, so you're going to study it properly. Okay, Iupac nomenclature system. The International Union for Pure and Applied Chemistry, that is IUPAC, put forth a nomenclature system based on the structure of the compounds, and it was accepted all over the world. So we are using it now also. Okay, there is a provision in this system for giving a unique name to all the carbon compounds. There are three units in the IUPAC name of any carbon compound: parent, suffix and a prefix. These are arranged in the name as follows: prefix, then you have the parent, and then we write the suffix. Okay students, now an IUPAC name is given to a compound on the basis of the name of its parent alkane. Okay students, so parent alkane is more important. The name of the compound is constructed by attaching appropriate suffix and a prefix to the name of the parent alkane. Now only we saw how it is arranged. Okay, the steps are there. Okay students, in the IUPAC nomenclature of the straight chain compounds are as follows. When they are straight chains, we will see how we are going to write the names of the compounds. We are going to follow some steps. Now the step 1. Draw the structural formula of a straight chain compound and count the number of carbon atoms in it. For example, I have taken propane. So 3 carbons. Okay. The alkane with the same number of carbon atoms is the parent alkane of the concerned compound. Means here my parent alkane, if 3 carbons, then the alkane will be propane. Write the name of this alkane. In case of the carbon chain of the concerned compound contains a double bond. Now from this 3 carbon atoms, in alkane you know single bond will be there between the carbon atoms. But one single bond are replaced by a double bond, then what it will become students? Propene, right? What we have to do? Change the ending of the parent name from ANE to ENE, right? Propene it became. If the carbon chain is the concerned compound contains a triple bond, okay, if it is containing one triple bond, then what we have to do? Change the ending of the parent name from ANE to YNE. Okay, propine it will become. Okay students, I hope step 1 is clear. We'll just see this table. It is given in your text. Please go through these tables properly students. Okay, now see here, you can see here you have the propane, ethane. Okay, you can see here straight chains are shown here. Okay, here also it has become ethane. So 2 carbons are there, 1 and 2, right? Here you have to take this carbon also. This is the functional group, right? But you have to take that carbon also. So it has become propane. Here see aldehyde, this carbon also you have to take. So it has become butane. Okay, you can see double bonds and triples bond also. So propene, and you can see what I took an example, propine. Okay students, I hope go through these tables properly. Okay, step 1 is clear to you students. That is, we have E, whatever the alkane, that is the propane, E is replaced by ENE when it is a double bond and YNE when it is a triple bond. Okay, fifth and sixth point you can see serial number. Now, step 2. If the structural formula contains a functional group, replace the last letter E from the parent name by the condensed name of the functional group as the suffix. Exception is there. The condensed name of the functional group halogen is always attached as the prefix first. Okay. Step 3. Okay, we are going to see it in the tables. We will be seeing, okay, in the next slide. The number of, what are our step 3? Number the carbon atoms in the carbon chain. We have to do the numbering, students, okay, to the carbon atoms from one end to another. Assign the number 1 to the carbon in the functional groups dash CHO or dash COH if present. Okay, if any of this functional group is present, students, we have to number this carbon as 1. Okay. Otherwise, the chain can be numbered in any two direction, from left to right or right to left, except that numbering which gives smaller number to the carbon carrying the functional group. Okay. In the final name, a digit, number and a character, that is letter, should be separated by a small horizontal line. We will see how it is separated. Now see here, students, this is our step 2 where you will be seeing that our the parent name like ethane, E, see this E is replaced by OL, okay, for alcohol, so it became ethanol. Okay, like that, if a Cl is attached, it will be chloroethane it became. Okay, first it is attached, then bromo, then if it is aldehyde we write Al, E is replaced by Al. Okay, students, if you have the acid OIC, carboxylic acid, so you have OIC acid you have to write. So see here, E is replaced by OIC, so it became ethanoic acid. Okay, amine, okay, amine, E you will remove, sorry students, and you have to write methylamine. Okay, then if it is a ketone, so you have to attach ONE word. Okay, E will be replaced by the ON. So students, I hope the table is clear to you. Okay, now should we proceed? Okay, students, so I hope you understood this. Okay, now this is the step 3. Okay, now if the the functional groups it is attached, see here OH, okay, alcohol, that means, right? So you, from where you will start the numbering, students, see here they have shown you. You can do it in this way also, 1 2 3, or you can do it in this way also. Any carbon you will see that OH is on the second carbon only, right? Even though you do the first or second type. Okay, so both the numbering is equivalent, so it will become propan, you will write dash 2 dash all, that is OL, all. Okay, students, I hope you understood how we are going to write it. Okay, now if you do numbering, now for second one, if I do numbering from this side, see here this chlorine is on, from this side if I do, it is coming on the 4th carbon, right? But if I do from this side, if I take this first, it will come here, it is going to come the 2nd carbon, right? So what I'll do the second only. Okay, least number it should get. Okay, students, so what it will become, see here it is shown 1 2, you can see this numbering, right? So it will become 2-chloropentane. Okay, students, I hope you understood how we are going to do numbering. Now here also I'll start the numbering from here, 1 2. Okay, and what it will become, students, you will see the numbering as I am telling you, right? And how I am going to write, pentan 2, and you will write it dash ONE. Okay, how to write you have understood. Okay, in this way only you will write, then only you will get the marks. Okay, students, now so I told you study those tables properly. This is one more table which is given in your text. You complete this, seeing this video, complete that table. Ethylene, CH2 double bond CH2, IUPAC name ethene. Acetylene is the common name, CH triple bond CH. Ethine, acetic acid, it is CH3COOH, it is ethanoic acid. Methyl alcohol is methanol. Ethyl alcohol is ethanol. Acetaldehyde we called it as ethanol. Acetone we called it as propan 2-ONE. Acetone, okay, what you call it as propan 2-ONE. Ethyl methyl ketone, you will write it as butan 2-ONE. Okay, you see the structures, draw the structures also, and write these tables you learn by heart properly. Okay, ethylamine, you will write it as ethanamine. and N-propyl chloride, normal propyl chloride, we write it as 1-chloropropane. Okay students, so all these structures you will draw and the IUPAC name you are going to write. I have given you all the IUPAC name. Okay, you will complete this table. Okay students, I hope it is clear to you. Okay, so now we will start with the chemical properties of carbon compounds. First one is the combustion. Hydrocarbons as well as most of the carbon compounds undergoes combustion in presence of oxygen gas, okay, to emit heat and light and form carbon dioxide and water as the common products. Some of the combustion reactions are as follows. Carbon plus O2, simple one you know, C plus O2 gives you CO2, right, plus heat plus light. Then methane plus 2O2 gives you CO2 plus 2H2O plus heat plus light. Ethanol, if you take CH3 CH2OH plus 3O2, you are going to get 2CO2 plus 3H2O plus heat plus light. Okay, you are going to write this reactions and study, students. Okay, so we are going to do a small experiment. Apparatus, you are going to require a Bunsen burner, copper gauze, metal plate, etc. Chemicals, you are going to require ethanol, acetic acid and naphthalene. Okay, procedure, what we are going to do students, place one of the above chemicals, 3 to 4 drops or a pinch on a clean copper gauze at room temperature. Hold it on a blue flame of the Bunsen burner, means I am going to just heat it. Okay students, and observe. Is smoke soothes seen to form due to combustion? Hold the metal plate on the flame when the substance is undergoing combustion. Does any deposit get collected on a plate? I am going to keep a plate so that when I am burning it, whether I am going to get anything in the plate, I am going to see, right? Like when you burn the magnesium ribbon, you are getting magnesium oxide white color powder on the plate, right? Which color? Repeat the same procedure using other chemicals from the above list. So I am going to repeat this heating for the all these compounds what I am taking. Okay. Now, in the above activity, ethanol is a saturated carbon compound. Okay students, while naphthalene is a unsaturated compound. Generally, saturated carbon compounds burn with a clean blue flame, while unsaturated carbon compounds burn with a yellow flame and release black smoke. Okay students, this you have to remember. It is this black smoke due to which a deposit of a black soot got collected on the metal plate. Comparison of the molecular formulae indicates that the proportion of carbon is larger in unsaturated compounds, student, than in saturated compounds. You will remember students, carbon is larger in unsaturated compounds than in saturated compounds. As a result, some unbound carbon particles are also formed during combustion of unsaturated compounds. You will see some of the black soot is getting collected. Now that is what? That is the unburned carbon particles. Okay. While in the flame, these hot carbon particles emit yellow light and therefore the flame appears yellow in color. However, if oxygen supply is limited, a yellow flame is obtained by combustion of saturated compounds as well. Okay students, there also you can get the yellow flame. Okay, I hope this activity is clear to you. Okay, now second part is the oxidation. I hope combustion you understood. You are going to do the combustion in presence of air and carbon dioxide gas you are going to get, right? Heat and light will be emitted. Now oxidation. Now what is oxidation students? See, what is your oxidation students? You have seen that the carbon compounds start burning by combining easily with oxygen in the air when ignited in air, right? In this process of combustion, all the chemical bonds in the molecule of the carbon compound break and CO2 and H2 are formed as the products. Yes, we have seen. Everywhere you can see you are getting the formation of carbon dioxide and water, right? In the other words, the carbon compounds is completely oxidized during combustion. Okay students. Chemical compounds can also be used as source of oxygen. We can use some of the chemical compounds as a source of oxygen. Okay. Substances that can give oxygen to the other substances are called oxidants. So some of the substances are there which can give their oxygen to the other substances and we call them as the oxidants. Okay students. Or we call them as the oxidizing agents. Okay. Potassium permanganate or potassium dichromate are commonly used as the oxidizing agents. Okay students, you will remember this. Potassium permanganate or potassium dichromate, we use them commonly as the oxidizing agents. An oxidizing agent affects on certain functional groups in present carbon compounds. Okay, so oxidizing agents can bring some change in the functional, means they can affect some of the functional groups which are present in the carbon compounds. Okay, so see this oxidation. Ethanol gets oxidized in the presence of alkaline potassium permanganate to form ethanoic acid. So you can see the reaction student. Ethanol I have taken, okay, CH3 CH2OH, in presence of, you can see, it will give oxygen, okay, and alkaline KMNO4, okay, what will be formed students? You can see ethanoic acid is formed, okay, COOH. See, this part is your what acid, right? Carboxylic acid. Okay, so what it is formed? It is formed the ethanoic acid. Okay students, I hope this part is clear to you. Okay, so on adding the pink colored solution of potassium permanganate to ethanol, the pink color disappears in the beginning. Okay, this is because potassium permanganate is used in the oxidation reaction. Okay, pink color, potassium permanganate, you have seen it is pink in color, so that color disappears. Okay, at a certain point of the addition, oxidation of all the quantity of ethanol in the test tube is complete. If the addition of potassium permanganate is continued beyond this point, it is not used up and becomes excess. But if I go on adding more and more amount, you will see that there is no color change, because whatever was required, the oxidation of that ethanol has taken place. Okay, the pink color of this excess potassium permanganate does not vanish but stays as it is. Okay students, so I hope this part is also clear to you. Okay, I hope both combustion and you have understood about this oxidation reactions. Okay, so today we have studied about, students, yes, first part we studied about system of common names, because there were very less number of carbon compounds, so common names were used by the scientists. Then we saw about the Iupac nomenclature. We have studied how to give the name, how to do the numbering, students. Yes, then we have studied, as I told you, all the tables are very important. You are going to study them properly. Okay, then we have studied about combustion. Yes, we have seen the formation of CO2, water, as well as heat and light is liberated. Okay, when there are the heating of the carbon compounds takes place, right? Then we saw about the oxidation, that some of the substances, they can give the oxygen to the other substances. We call them as the oxidizing agents, right? And yes, we have seen potassium permanganate and how the ethanol can be converted to ethanoic acid. Okay students, I hope today's part is clear to you. You will go through the presentation properly. Okay, we'll meet in the next presentation and continue with the lesson. Okay, thank you. Sai Ram. Take care.